So this is section 8.6. We're going to break this one up into a couple of different lessons because this is a little more difficult. So first, I'm going to review what we should already know. We should know how to factor a problem like this. Today's going to be different. So just look at this for an example, everyone. When we factor, and this first value is x squared, it's really easy. It's not going to be x squared. If you look ahead, if you're on the notes, on here, you're going to have a 6, a 3, a 10, a 6. That's going to affect things differently. So what you should already know is when you do one like this, we put x and x. Then we always look at the last number, and we come up with all the ways to multiply to get 12. Again, going through this kind of slow, how do I come up with the different ways to get 12? I take a calculator. You could take a computer, type it in. But what I do is I take the 12, divide by 1, tells me 1 times 12. 2 times 6. 3 times 4. Now, I'm not going to repeat any numbers, so I write all those down. And what I'm looking for, I look at the last sign. I read kind of backwards. I look at the 12 first, then I look at the plus. They have to add up to 7. Well, we understand that these two, 3 and 4, add up to 7. But I'm going to be more specific now. When I put these in, the positive 3 and the positive 4, the check is going to be really important today. When you multiply this one times this one, that is a positive 4x. And this one times this one's a positive 3x. And those are what actually have to add up to the 7x. Over here, today's lesson, you're not going to see it as easy. What you're going to have to do is you're going to have to do the multiplying. You'll see what I'm talking about as we get into this lesson. But that verifies it's 7x. So this would be the answer to that problem. Okay, but this next problem, part A, I'm going to write these out. Actually, today we're only going to do these 4. That's going to be the entire lesson. Then we are going to do a little bit of some work on the worksheet. So I'm going to write out A a little bit larger just for the sake of seeing it. 6x squared plus 13x plus 5. Today's lesson, you aren't just going to go x and x. You will have an x and an x in both to get the x squared, but you now have to also deal with the 6. So the 6 is the first number, and there's 2 ways to get 6. 1 times 6 and 2 times 3. The last number over there is 5. We're still going to have that same rule. We look at the last number, and fortunately, there's only one way to get 5, and that's 1 times 5. There's no other way to get it in terms of integer numbers. You know, of course, 2 times 2.5 works, but we're not going to deal with any decimals, okay? Now, you have a choice. You could either, don't write this down, you could go 1x and 6x because that would get you 6x squared. Or you can go 2x and 3x. My suggestion when you do these is try starting with the pair that's closer in value. 2 is closer to 3 than 1 is to 6. 1 and 6 are 5 numbers apart, 2 and 3 are closer. Because a lot of times when you do them, the closer pairs will be the one that works. So when I'm talking about the closer pairs, hopefully that makes sense. Okay? But now, if I multiply these two, 2x times 3x, we would get 6x squared. That's correct. Now, over on the other part, when we look at these, this problem was really easy because 3 plus 4 is 7. The problem here, when I look at this, one plus 5 is 6. It's not even close to 13. And the reason for that is because we need to put these values in, and we need to remember they will get multiplied by something else. So, for instance, I'm going to take the 1 and the 5, and over here, I'm going to put a 1. Then here, I'm going to put a 5. Now, since it's positive, they have to add to 13. Whenever it's positive, that means they're either both positive or both negative. Well, how will I know? If it's positive, they have to be the same. Then I look at the middle term. If it's positive, they both have to be positive. But here, these two, where I've drawn this loop, 2x times 1 would be a positive 2x. Then I draw this loop, and that would be a positive 15x. Now if you look, if I add those, that gets me 17x. So we can see that 1 and 5, even though that adds up to 6, that won't help us. What we have to remember is they have to multiply. But we didn't get it right. We got 17x. We want 13x. If I switch these around, it might change things. And the reason it might change things, if I put the 5 here, now when I multiply, it's not 2 anymore, it's 10x. And then I put the 1 here and I multiply, I get 3x. And when I add them, what do I get? 13x. Okay, so that's the new trick that we have today. All right, so you have to make sure that you check these in terms of multiplying, and I just call them check the loops. They used to call them inner terms or whatever. You want to make sure that they multiply to get the correct middle term. Is that making some sense? A little bit. Okay? Now, it really is what we call a guess and a check process, but if you've learned the steps that I gave you with the initial ones, then you'll understand, okay, why I make you write those things down, because then you can think through. Eventually, you get better at it where you can do a lot of them in your head without writing those things down, and that's great. Okay, but we want to have good habits, so let's try this next one. The next one says 3x squared plus 7x plus 2. All right, so I look at the first term. The first term is 3. There's only one way to get that, 1 and 3. So 1x and 3x. Now, some people say, what if I did this? And I apologize if I'm going to mess you up already. What if you go 3x and 1x? That's the same thing. Doesn't matter which one you put first, because what's going to matter is when you look at those loops, when you look at what you multiply, that's what's going to be important. But now 2, there's only one way to get 2. 1 times 2. So, some of you may already see the answer, but whatever I put here gets multiplied by 3. Since it's positive, they're going to add. They're both going to be positive. Whenever it's both positive in the problem, it's going to both be positive in their answer, in the solution. That's a nice thing to remember, both positive. But that 1 times 3x is a positive 3x. Then over here, if I put the 1 here, I have to put the 2 here, and that's going to be positive 2x. I got close, but that only adds up to 5. It doesn't add up to 7. So what happens if I change them around? Now when I multiply these two, this one times this one is 6x. This one times this one is 1x. Since they're both positive, that adds up to 7, so that's my solution. If you switched them around and you wrote your answer like this, you wrote x plus 2 times 3x plus 1, you're correct as well. And why? If I ask you, what is 2 times 5? What's 2 times 5? 10. Well, what's 5 times 2? 10. So it's just like that. It's just taking two numbers and multiplying them and putting one first and then the other first. You'll get the same thing. If I multiply my answer and you multiply your answer, we will both get back to this. There's no doubt. Okay? Because it's the same two numbers. It's just like 2 times 5 and 5 times 10. Both of them get, or 5 times 2. 2 times 5 and 5 times 2 is 10. Okay? So we look at the next one. Part C. 10. X squared plus 31x minus 14. This one is going to be a little bit longer because it's got more options. Okay? First of all, you have to look at the 10 And there are 2 ways to get 10. 1 times 10 and 2 times 5. I advise that you try the closer pair. 2 and 5 are closer together than 1 and 10. But 1 and 10 could be the answer. Okay? It could be. But after I come up with that, I still look at the last number. The last number is 14. What's going on with the board here? Something weird. 14. 1 times 14, 2 times 7. And again, if you're not good with coming up with all those values, you take the 14, you divide by 1. It works. 1 times 14. You divide by 2. 2 times 7. You divide by 3. Throw in a dot if you're not sure. That didn't work. You divide by 4. That didn't work. Since the 3.5 is smaller than the 4, the number you divided by, when it gets smaller, you're done. You do not have to keep going. Do 5. That's smaller. You should have been done before. And you don't have to go to the point where you get 7 again, because you already have 7 and 2. You don't have to repeat it and put 7 and 2 and 14 and 1. It kind of loops around, I always say, so we're done. Now, I started with the 2 and the 5 because they're the closer pair, so I'm also going to start with the 2 and the 7. Now, it doesn't always work perfectly. Sometimes it is the bigger ones, okay? But we have to put these in here. Now, this one is going to be different. It's negative. So they're going to have to subtract. When it's negative, that means one of them has to be negative and one of them has to be positive, okay? So they are going to subtract and get 31. All right? So I'm going to put the 2 here and the 7 here, and we're just going to take a guess at it. Now, if you have pencil, it's good. You write in pencil so you can erase or write lightly or something like that. If you have pen, then you're going to have to write maybe smaller and scribble it out, so you get your answer in there eventually. If you need a pencil, ask me. But this, 2 times 7 is 14x, and 2 times 5 is 10x. Now, there's still the rule. The bigger group should be negative. So if this were the case, I would make this one the negative and this one the positive. So that's a negative, that's a positive. They have to subtract. That's going to get me negative 4. It's not even close to 31, is it? Agree? Not even close. But we're starting to get the idea. It's always got to multiply by the other one. It's not automatic. Like 2 and 7, that subtracts to 5. It doesn't even come close to 31 either. But if we switch these, and we put the 7 here. Now 7 times 5 is 35x. I'm going to make that negative because I'm making it positive because I'm trying to get, I should have made that last one, sorry, I should have made that last one positive. The bigger one should have been positive. The 14 should have been positive. I was wrong. But it didn't matter because they didn't subtract to 31, right? Okay? So here, I'm making that positive because that will be close to 31x. See it? We're close. Now this one I'll make negative, and a negative 2 times 2 is minus 4x. Oh, and now when we subtract, we get the 31x. But you have to check, and you have to pay attention to detail in your multiplying those loops. Now, do you see why when I taught before the other lesson, why I was always specific about writing these things down? It's not because it's busy work. I want to teach you how to think it through. And then when you get good at it, I don't care if you write it down. But if you don't have a method to get there, that's what I'm trying to teach you, is how we think this through. All right? So now, sorry, finger hit the board wrong. Part D, last one that we're doing in the notes here today. I know there are more notes, but I'm going to break this lesson up into a couple because it's harder. I want to make sure that, we look at these a couple days in a row. 6x squared. We have a 6. This is the first value. So we could have 1 times 6, 2 times 3. I'm going to take a guess and make it 2x and 3x. If you say 3x and 2x, fine. That's the same thing. Okay? It could be 1x and 6x. The last number, 6. Well, this is the last part. It's the same, 1 and 6, 2 and 3. So these are my first numbers. I'm going to start with the 2 and 3 as the last numbers and see if I can work it out. Now, one of the things, if you get good at it, you'll start to recognize things a little bit quicker. Since it's positive, I know they both have to be positive. Since both are positive, they have to add up to 13. I'm going to put the 3 here. That's positive 9x. Then I'm going to put the 2 here, and when I multiply that, that's 4x. I got 13x. Sometimes you're going to get it right away. That's the hope, that you can recognize how it's going to get you to 13. Make sense? But it's not as easy as last time. Why? Because these two will never add up to 13 when you have beginning numbers that aren't just x squared. So when you have the ones that are just x squared, they work out a lot easier. Okay? So now, I'd like us to take the worksheet. I'm going to do a couple problems on the worksheet. The worksheet 8.6. I'm going to continue to film, so if anybody's at home, they can watch this as well. We're going to look at number 1. Now, number 1 takes us back to where we're multiplying. Everybody should be able to do this, but we'll review it. Factoring and multiplying are the opposite of each other. Multiplying, you multiply and put them together. Factoring, you break it back down to what they multiplied to. So here, 2a times a, 2a squared. 2a times negative 7, negative 14a. Now we are done multiplying the 2a. The 2a got multiplied by both terms in the other one. 3 times a, positive 3a. 3 times negative 7, negative 21. The two terms that I put in red, I did that on purpose because they're like terms. They both have just an a. The other one doesn't have an a, and the other one has an a squared. So now we put those together. We get 2a squared minus 11a minus 21. The 11a, we put them together, we group the like terms. So those top 4 are part of the assignment. I think we can all do the other 3, correct? All right. So next, I'm going to do the hardest one. Today, all I'm asking is that we do 1 through 8 on the worksheet. We're going to break this worksheet up into 3 days. We're going to work on it because it's a little bit harder. We're going to need more practice. So I want to give us more practice where I teach a little bit of a short lesson each day. We do some problems, and then we'll have one day where we do the rest of the worksheet. So I'm going to break it up a little bit. So today, all you have to do is 1 through 8. We already did number 1. So right now you got 2, 3, 4, 5, 6, 7. We're going to do number 7 and then number 8. If you get done with number 8, that's going to be fine. Okay, but number 7. I'm doing this one because it's the hardest one of the 8 that we're going to do. We have the 14q squared. We're going to break the 14 down. That's our first number. 14 can be 1 and 14, 2 and 7. I'm going to start, and I'm going to guess that it's 2q times 7q, but it could be the 14q. We haven't run into that. We'll probably run into that tomorrow where it's one of the bigger ones. It just, a lot of times it ends up being the smaller ones first, and then we go from there. 63. Now again, when you get bigger numbers, sometimes people get intimidated. I hope you know your multiplication tables. But if you take 63, you divide by 1, you write that down. 63 will not divide by 2. Okay? Now, here's a clue. If it doesn't divide by 2, it will not divide by any even number. So you do not have to check 4. You do not have to check 6. you do not have to check. 8, 10, any even number you don't have to check. So that makes it a little faster. So I'm going to take 63 divided by 3. It works. I'm going to write those down. So far I have 1 and 63. 2 didn't work. 3 and 21. I could write them neater when I get done. Now, I don't have to check 4. I don't have to check 6. I'll check 5. If you know the rules with 5, the only way 5 will work is if it ends in a 5 or a 0. Okay? I don't have to check 6 because it's even. 63 divided by 7 is 9. So I have them all. You can try 8, but 8's even, and then 9 is going to be a repeat. So I'm going to see if 7 and 9 get this to work out. Now, it's positive, so they have to add to a negative. That tells me they're both negative. If the last number is negative, one's positive, one's negative. That's where it's usually tricky. But here they're both negative because it's positive. They have to be the same sign. That tells me they're the same, and they're both negative. So I try 7 and 9. So I'll put 9 here, 7 here, just take a guess. And 2 times that is negative 14q. 9 times 7 is negative 63q. If you put those together, that's negative 77q. It was close. But we want negative 67, so that's not right. So I took a guess, and I checked. It's not right. I then do what? I switch them to see if that works. Because sometimes it switches. Why? 7 times 7 is different. 2 times negative 9 is negative 18q. 7 times 7 is negative 49q. That is negative 67q. That's the solution to that one. I did the hardest one of those 8, so do those first 8 today. You do not have to upload anything to Classroom.